Hello everyone and welcome back. Today I'm going to talk to you about the difference between SQL and NoSQL databases. I'm going to start out by defining what SQL and NoSQL is, followed by some general guidelines on how to pick one over the other when starting a new project. So let's start out by defining what SQL is. So SQL stands for Structured Query Language, and the language typically looks like what we have on the right here. So SQL allows you to perform some create, read, update, or delete, also known as CRUD operations, through a universal language that is pretty much consistent across multiple different underlying relational database engines. So as I said, there's multiple different underlying relational database engines, and these typically are things like MySQL, Postgres, or Microsoft SQL Server. So there's four key components that I like to talk about databases. So there's structure, storage, scale, and access. So let's quickly go through these and talk about how it relates to SQL. So starting in the top left with structure, you typically interact with tables in a relational database engine. So as an example, we have an accounts table here, and a table consists of rows and columns. The columns correspond to the types and the rows correspond to the individual entities that exist in the table. So we have an account ID here, we have a creation ID and a country ID, and every row here is an entity or an element. So A1 is the account ID, it had a creation date of September 30th, and its country ID is number 1. Now in a SQL table, you must have a primary key, and a primary key corresponds to the unique identifier that identifies a specific row. So in this row's case, the primary key is A1. You have attributes that correspond to just general data about the record, and then you can also have things called foreign keys, which are links to other tables. Now, SQL databases also enforce constraints. So for instance, down here, we're seeing that the account ID column is only allowed to be a variable character or a string. Similarly, the creation date is only allowed to be a date, and the country ID is only allowed to be an integer. These constraints make it such that if a user is trying to insert or update data, and the data violates the constraint that's imposed on the table, the operation will fail. So this is a great way to enforce consistency across the content of your tables. Thirdly, possibly the most important, is that we have relations. And let's just bring up a second image here that has a relationship. So in this table, we have the accounts, which was what we originally had previously. And we saw that we had a country ID with this vague name here. So country ID 1. And separately over here, we also have a country table that exists on its own. And in there are the identifiers for each of these country IDs. So country ID 1 corresponds to USA, 2 for Canada, 3 for Australia, so on and so forth. So what SQL databases allow us to do is build relationships. So we can say country ID 1 corresponds to USA, 2 to Canada, and 3 to Australia. What this allows us to do is perform some very flexible queries, such as give me all the accounts where the country ID is equal to USA. Now in terms of storage, the storage pattern is concentrated. So in a relational database engine, there's typically one node that contains an entire copy of your data. It's typically not partitioned or segregated in any way, unless you're using some advanced strategies. Now down to the bottom left in terms of scale, there's two approaches here. So the first one is vertical. So if you have a machine that's hosting your database engine and you're suffering in the performance area, the option here is to build a better machine. So have more memory, get a better CPU, add a faster hard disk. These are ways to vertically scale your machine so that you can get better performance. Keep in mind here that there is a physical limitation in terms of how powerful a machine that you can make. So there is an upper ceiling on vertical scaling. The second approach is horizontal, which just means adding more machines. And when you add more machines in a horizontally scaled RDS environment, you typically perform that by distributing your data across multiple nodes. So in a horizontally scaled environment, you have one master, and then you have multiple read replicas. So when traffic is coming in, not only can that traffic read off of your master, but it can also read off of your read replicas. So what this allows you to do is to offload some of the pressure from the initial master node onto read replicas so that you can ensure optimal performance on your database. Now in terms of access, it's typically raw SQL, so writing the raw create, read, update, and delete syntax for your query. You typically require a direct database connection to the endpoint of the database, and typically these days people are using object relational mappers to construct their queries, and what these basically are abstractions that people use to add criteria to an object in a very programmatic way, and then allow that to generate a SQL statement that can be run against the engine. So we've basically covered the 4 key pillars of SQL here. So let's move on to talking about what is NoSQL. So although it probably doesn't need to be said, it's anything that is non-relational. And there's many different implementations of NoSQL, so it's kind of an overloaded term. There's implementations that use table structures, similar to what we saw in the SQL approach. Some use document and some use graph. And the basic idea here is that NoSQL is built to scale with high performance, but it also comes at a cost. And that cost is that your queries are less flexible. So let's go through the same exercise as we did before and talk about the structure, storage, scale, and access. So in terms of structure, it is very implementation dependent. So as I said, there's table implementations, there's document implementations that store JSON objects under the hood, and there's also graph databases. So say for instance, something like a Facebook social network where you have friends and those friends also have friends. A graph database is a perfect representation of that domain. But the general theme among all of these is that they rely on key value stores. So generally in a NoSQL database, you need to know the key that you're looking for when you are performing your query. In terms of storage, it relies on hashing the input. So if you have a key that you're looking for, that key is given into a hashing function, and the result of that hashing function is a value, and that value is distributed onto one of multiple nodes. So say for instance, if we had key 123, the key 123 would be inserted into the hashing function. The output would be a physical location on partition 1 where that data row is stored. And if you think about what this looks like from the read perspective, now the same kind of concept applies. So the same hashing function is run when the key is provided, and the engine knows exactly which partition to find the record on. In terms of scale, it's a very simple process, and that is to simply add more partitions. So instead of having the 2 partitions like we had in the top right, in this example, we can just add 4 partitions and allow those individual partitions to scale individually. So add more disk storage, add more memory, add more CPU. Typically in a NoSQL database engine, all of this is managed for you, so you don't have to worry about the underlying details on how to add more partitions. Now moving on to access, there's 2 major flavors here. The first one is REST APIs, and you use REST APIs to hit a specific endpoint that has a certain functionality associated with it. Optionally, you can perform create, read, update, or delete in vendor-specific languages. So if you're using a vendor like DynamoDB, that will have a very different way to perform a query as something like MongoDB, which is another NoSQL option. So now that we know a little bit about SQL and NoSQL, let's move on to talking about when you should use what. So here we have a SQL and NoSQL table. So let's firstly go through why you would want to use SQL. So when your access patterns aren't defined, if you don't know how your business use case is going to evolve, and you're not sure if the way you're storing your data is going to allow you to query it in an effective way later, then using SQL is definitely the preferred option. Secondly, when you want to perform flexible queries, this kind of ties into the first point. If your access patterns aren't defined, you won't know what queries you're going to perform. So it's important to stay flexible so you can adapt to changing use cases. Third, when you want to perform relational queries. So this really is the bread and butter of SQL engines. If your domain is by definition relational and you want to perform queries that can make multiple hops among different tables, then SQL is the choice for you. Fourth, if you want to enforce field constraints, this allows you to normalize and keep your table consistent so that malformed data cannot make its way into your table. And lastly, for SQL, when you want to use a well-documented access language, SQL is generally universal across all the relational database engines that are underlying. So you can find a ton of support, and there's a ton of different communities that you can learn from to help you solve your problems. Now moving on to why you would want to use NoSQL. So when your access pattern is defined, so when you know exactly how you're going to be interacting with your database, it's definitely a time to consider NoSQL. Secondly, when your primary key is known, this is part of the limitations of NoSQL. As we were talking about before, the input to the hashing function is your primary key. So if you don't know your primary key, you're not necessarily going to be able to find the data that you're looking for. And thirdly, when your data model fits, as I was alluding to before, in a Facebook type domain where you have friends and they have friends, that's a very natural fit for a NoSQL graph-based database. So NoSQL may be a choice for you. And finally, the most important one, when you need high performance and low latency, this is where NoSQL shines. It can scale out horizontally pretty much infinitely while maintaining a consistent high performance and low latency. So now that we've done a little bit of a comparison here, let's walk through some example scenarios of when you would pick one or the other. So how to pick. So if you have a small project that's low scale with an unknown access patterns, you're better off using SQL. So if you're just starting out and you're not really sure if your product is going to take off and you don't necessarily know how it's going to be used, SQL definitely makes sense and is probably the best choice for you. And secondly, maybe you have a large project that is high scale that requires relational queries. I'd highly suggest using SQL, however, using a managed solution with read replicas so you can ensure high performance and consistency for all your customers. Now, the main option here, since this is an AWS channel, is to use Amazon Aurora, which is a fully managed SQL database. They also have an alternative option called Amazon RDS that allows you to use a different underlying relational database engine such as MySQL, Postgres, Oracle, and others, and still gives you that managed functionality and allows you to have read replicas, monitoring, and everything else that goes along with a managed database engine. And if you have a medium or large project that is high scale and requires high performance, then NoSQL is definitely the choice for you. So there's typically two engines in the AWS ecosystem. There's DynamoDB, which is by far the most popular and most developed. And there's also MongoDB. And MongoDB has a canonical name, DocumentDB, in the AWS world. So if you're looking for Mongo on AWS, DocumentDB is the choice for you. Unfortunately, I can't recommend NoSQL for small projects. I think NoSQL is a better fit for those that have an established use case that require ultra-fast performance and high scaling abilities. So if you like this video, I have a great DynamoDB playlist that you should check out. Also, please don't forget to like and subscribe so you don't miss out on next week's video. Thanks so much, folks, and I'll see you next time.